Hello, everybody, and welcome back to DJ Tutorials. This is part 8. We're going to be changing our settings from the eevee engine over to cycles. So if you haven't done that, please go back and do that since we are going to be using the eevee settings as a baseline for the changes we're going to make for the cycles engine. And what we're going to do first, before we start anything, is we're actually going to download some IES textures. And if we go and do a search for free IES texture packs, we should be able to find some right here from Leo Moon. It says right here, pack of 32 IES lights made to use in our architectural renderings. Now you can use these light profiles for free. So you can go ahead and donate. Please donate so that they can get some, money back. But you can find any IES light packs online. There's a lot of them there for free. A lot of companies that make lighting fixtures and stuff like that will send these out to architectural visual designers and visualizing companies so that they can use it in their renders to sell their lighting kits. So you should be able to find a good amount of these, but this is the one that I have. So you can go ahead and download those IES light textures here. And what we're going to do is we're going to be switching out our lights for the IES textures. But first, before we do that, let's go ahead and change our render engine. So since we're going to be using cycles, you're going to go over here to the Render Properties tab, change this from eevee to cycles, and make sure to enable your GPU device, GPU compute here. And since we're going to be jumping into this ray tracing engine here, I'll just show you how you can change a couple things. If GPU compute is not available and you know that you have a discrete GPU, go up to Edit, Preferences, and then you'll go to System. And then if you have an NVIDIA card, you'll use CUDA. Don't use optics for now. That uses the ray tracing cores, and there are some things to be gained, but there are also some issues with this rendering style, so don't use this for now. And then if you have an AMD card or something like that, you will choose OpenCL, and that's where you can see mine. So I have my Radeon 7s here, and I also have my CPU here. So I'm just going to be using the one Radeon 7. I don't need to use any of the other stuff here. And if you go ahead and save those preferences, go over to device and you should be able to choose between the CPU or the GPU compute. Now, Cycles is a tile-based ray tracing engine, and what that means is that'll kind of make sense when we actually do the render, but for right now, let's just change this to rendered here in this view. And yours will probably take a little bit longer than mine. I do have some pretty expensive equipment in my machine, but basically what you're seeing here with all this grain is that's actually a ray tracing engine. So it calculates light based on bounces more realistically to the camera and provides a more realistic rendering of what these objects would look like. And you can see here that there are some softer shadows than what we saw in the eevee engine. And in general, the image looks a lot more, I guess you could say, realistic. We won't have to change a whole bunch of those settings like we did in eevee to make it look more realistic because since it uses ray tracing, it already calculates certain things like distance between objects and the screen space reflections and things like that just on a default. Now, what I'm going to do right now is I'm going to set this up to render so I can actually show you the difference between the IES lights that we are going to be using and the area lamps here, which these are fine. It's just IES light textures are actually much more realistic in how it represents lighting in the scene. So let's go ahead and change a couple things here so that we can get a more efficient and better render. So what I'm going to do is first I'm going to go over here to the output properties. And over here, there's a little box that says render region. And that has to do with your viewport display right here. If we click this box, it will only render within the panel here for our camera, and it won't try to render anything outside of it. So we actually save on our render uh, device, and it will just calculate the stuff within here. The next thing that we're going to do is we are going to go to the render properties and we're going to change the amount here to 200. Let's actually just multiply this by 2. So 128, hit the multiplier on your numpad, and then 2, and you'll have 256 samples. For light paths down here, this basically is telling the render engine calculate this many passes for each of the types of materials that are in the scene. So diffuse is 4, glossy is 4, transparency is 8, and all that kind of stuff here. So this can get fairly complicated. And really, all we have here are diffuse, glossy, which are the reflective bits here, um, and that's pretty much what we have. We don't really have any transparencies. We don't have any transmission. We don't have any volume. So that's really all we have here. So we're going to bump this up actually to 12 diffuse and 12 glossy. And it will take a little bit more time for the computer to, for the render device to render these passes. But if you increase these, the number of bounces here, that will actually help your render. And then if you decide on your own you want to increase this to anything above for the total number of bounces, you can feel free to do so. You can go in here if you click this little icon here. You can click on the full global illumination, and it will add like over 100, I believe it is, passes for all this stuff for a full sample. You're more than welcome to do that if you'd like. I don't think it's really necessary for this scene and what I'm trying to show you, but you're more than welcome to do that if you'd like. We're going to go ahead and close that down there. And we don't really need anything in here, so that's all fine. Now we will be adding one more thing onto our render pass, and if we click on this little layer properties tab right here, there's a whole bunch of stuff in here. So let's just make this a little bit easier to see, and make sure that you have the passes open, and then we're going to open up data. And what you're going to click on is this button right here that says Denoising Data. And what it will do is when it's rendering out the image, it will add another pass to analyze the tile. And I'll explain what that is once it renders. And it will basically use the data that it renders to denoise the image so that we can use less samples for a more high quality final image. So I'm going to render this out now with these settings. And you don't need to do this. I'm just doing this because I'm going to show you guys the difference between the IES Light Textures and this sort of setup that we have here. So here we go. So I'm going to go solid here just to save on my GPU render device and the RAM or the video memory, and save the file and then render image. So F12 there. And so what you're seeing actually, I forgot to do one other setting. You're actually seeing the tiles being rendered. This is my one GPU, and it's rendering, pretty good for this sort of image. But what I'm actually going to do is I'm going to enable some other devices to show you how yours probably will look. So I'm going to hit escape here. And when you hit escape while it's rendering, you can actually cancel the render. So I'm going to hit X here. I'm going to just close this down. I'm going to go back to Edit Preferences, and I'm actually going to enable my CPU. And just for fun, I'm just going to do my both of my Radeon 7s and this Threadripper here. So basically, all my render devices, I'm just going to turn that on so it's faster. And what I'm going to do is I'm going to go to another area here called Performance. Now, I have an add-on that's called, it's an auto tile size sort of thing that automatically calculates, but basically, all really what we're doing here is we're going to look at this area right here that says tiles. And if you're rendering on CPU, the smaller the tile, the better. If you're rendering on a GPU, generally speaking, 250 to 256 to 512, somewhere around there for the tile size works pretty well. Since we're using CPU on this, and the way that GPU and CPUs kind of work, the tile size, is better if you are gearing it towards that CPU size. So usually the smaller the better for a CPU render tile size. So where it says tiles, we're just going to type in 32 and 32 here. And it didn't change. So let me just turn that off. 32 and then 32. Okay. So again, I have this add-on. You probably don't have it, so you can just type it in without any issues. But basically, the tile size is going to be 32 pixels by 32 pixels. And I'm going to save here. And don't worry too much about this Hilbert spiral here. We're just going to leave that as it is. And don't worry about anything else for now. And we're going to hit F12, and I'll show you what happens. So a tile size or a tile renderer, all of these orange squares that you see here are basically tiles that are being rendered by each, um, I guess, thread of your device. And, sorry if this is a little bit over your head. A CPU with, let's say, 8 cores would have 8, and if it was hyper-threaded, meaning it would have double the amount of threads, it would have 16 of these little tiles. And then if you're adding GPU devices on top of that, for me, I have two Radeon 7s, so there would be two more of those tiles being rendered. Now, I have a Threadripper 3960X, which has 24, it's 24 core, 48 threads. So I have 48 tiles plus two because of my two Radeon 7s, and this is what we're seeing. So as it's rendered out, you can see that it just goes in this spiral here, what's called that Hilbert spiral, and it's rendering out these tiles one by one as it goes. And just make note of this because if you're going to look at the Radeon Pro Render um, uh, part, which I really recommend you looking at because it will uh, have a different way of rendering. You can see that this is basically how this is being run here. It's just going around and around in a circle, and all of these little tiles are being rendered. And you can track everything that's going on up here. You can see the time that it's taking. You can see the remaining time that it's being calculated, the number of tiles rendered, and then the number of tiles total that's going to happen. And as far as the pre-filtered, that really has to do with that denoising sort of thing there. So we're just going to let it finish up its render, and then I will be saving out the comped version of this. Okay, and there we have it. This is the final render of this particular setup with the same node setup that we had before for the compositor. And you can see there's a little bit of an issue over here on the left. And I'm going to see if I can resolve that in just a moment. So after playing around with this for a little bit, I realized that this denoising is not really going to work the way that I would like it to work for this particular project. So what we're actually going to do is we're going to add the depth of field in the camera. So lucky for you, you get to find out how to do this. So we're just going to close this out here. And here is what we are going to do. So I'm just going to delete some of this stuff here. And what we need to do is we need to click on the camera up here in your tree. Make sure that you have rendered view over here on the right. And we are going to add right here this little button. If you click on the camera object properties, down here there's a button that says depth of field. So if you click that on and you hit the little down arrow, there's a few things here that you can see. There's a distance, a focus object, aperture, and all this. Really what we want to do is we want to focus on this sort of section right here. So what we're going to do is we're going to choose the cylinder as our focus object. And how we do that right here, see where it says focus object, you can click this dropper and then select the cylinder or whatever object you would like to focus on. You could even make it an empty that you move around wherever you would like. And then what we're going to do is we're going to change what's called the f-stop. And the f-stop basically means the lower the number, the more defocused everything gets, and the higher the number, the more in focus everything gets. So I'm going to zoom in a little bit over here and make it to where you can see this a little bit easier. And I'm going to change this f-stop to a 0.5. And when I do that, you can see that now the cone is kind of more softly focused, and in the foreground, the cube is not as much in focus. And that kind of matches what we were doing before. Um, it's not as easy to control as far as in post in our compositor to do this sort of thing. You could add another denoise on the top and do some other stuff like that, but really, I am trying to keep this as simple as I can for you guys, but also getting you a really nice final render at the same time. So we're just going to go with a 0.5 right here, set the focus object to the cylinder, and we're going to render this out. Now, because we are using a defocus or a depth of field on our camera, we will usually need more samples for this defocus. But I think that 256 will work just fine, especially since we turned on the, not this, we don't want that denoising, since we turned on the denoising data pass here. So I'm going to change this view and put it on solid, and I'm going to save my file, just make this a little bit smaller over here. And we're going to hit F12 to render. And we'll watch this render and I'll speed it up for you guys. Okay, so we have it finished, and it looks like, of course, the compositor is still setting the other things in there, which we're going to fix in just a moment. But you can see here that it took 4 minutes and 41 seconds. So definitely a lot longer than it did the eevee engine. And for you, if you do not, I mean, I'm assuming most of the people who are going to be watching this do not have two GPUs, especially the ones that I have, and a Threadripper series CPU, you may want to go down to 150% on the output settings here. Maybe do 150% instead of 200 here, or just be willing to wait for that render because it could take quite a bit of time. So just fair warning to those of you who are seeing this take much longer than mine. I do have a much more robust sort of system than a lot of people have, and I understand that, but that doesn't mean you can't get a really nice render. So let's take a look at our compositor here, and we don't need this anymore, so we're just going to take this normalize here, and we're going to accidentally hit Z, which changed this zoom here. So let's just move that back over here. And we are going to take this normalize. We're going to delete that, take the color ramp, delete that, defocus, delete that. And since we already have a defocus, since we use the depth of field on our camera. So we're going to take the image here, and before we actually start to do anything with this, we're going to add a new filter. So go to Filter, Denoise. And you'll see that this looks much different than the eevee render of our image. And what this is it's giving us denoise information. The easiest way to do this that's very painless is that you take the image and you pipe that into the top of the denoise. Then, where it says normal, you just take the denoising normal, you pop that right in there. And then for albedo, take the denoising albedo and pop that right in there. And if I link this to my viewer, and I'm also going to show it to you in the compositor so that it's a little bit bigger here. So there we go. If we look in at it, it's very, very clean. There's really not a whole lot of grain going on and all that. Now, if we look at the regular image, and zoom in, you can see that there's grain here. You guys see that? So there's grain, and then take the denoise and pop that into the compositor so that we can see it change. So here's the grainy part, and wait for the compositor, and there we go. It cleaned up all that grain. Now, I actually kind of like the grain sometimes. Sometimes you don't want the grain. It's really up to you and how you want to do this. It's a little bit smooth for me, and I'm losing some of the really nice sort of like cinematic look with that, grainy look. So I am going to not use the denoise for my final image. I'm going to just pipe this straight from here into the glare, and then that goes into the lens distortion from before, and I'm just going to pop that into the viewer and into the compositor, and this will be what we get for the final image. You have to wait for the compositing. Yeah, so it's still compositing right down here. You can see that. Okay, and there we go. So this is the sort of final image. Now, I would probably do a little bit more samples to kind of reduce the amount of grain here, but I think this is okay. And especially when we take this into, I'm not going to show you how to do this right now, but when you take this into GIMP or something like that, reduce it down 50% for your final image, you're going to have something that's really tight and looks really, really nice. So now this is using that regular lighting setup. We're going to be changing that around to an IES lighting setup, but I'm going to go ahead and save this so we can actually compare the differences once we're done. Okay, so the next thing that we're going to do here is we're actually going to set up our IES lighting texture and our Blackbody colors to match more realistically what we would actually see in real life. And again, kind of the point of doing some CGI, at least in my opinion, is to try to make things look as realistic as possible. Now, what I'm going to do is I'm actually going to take this light target here. I haven't done this yet, I just forgot. Take this light target, left click and drag, and put it into the collection with the camera here, because we're really not going to mess with that. So what we're going to do now is we're just going to take these three lights. I'm going to hit Shift D to duplicate, right click to set them right back where they were. Then I'm going to hit M to move to collection, click on New Collection. We're going to call this IES Lights. Okay. Then over here on our tree where it says 3-point, let's uncheck that box so it goes away and we don't see it. And here under our IES lights, let's go ahead and change all these names here. So fill light, I'm just going to remove the dot 001 to do an underscore IES. And I'll do that to the remaining lights. Underscore here, IES. Okay. Now, in order for us to view this properly, what we're going to do is we're going to turn off all the other lights in the scene. So I'm going to go to the world settings here, turn the strength down to 0. I'm going to turn off our rim light, or at least turn the eyeball off here. And then for the fill light, I'm going to turn that off as well. And we're going to start with the key light here, just like as we did before. So we're going to then split this panel up here by left clicking and dragging down. And then here, change this to the shader editor. So not this one, but this one right here, shader editor. Okay. And we don't see anything in there yet, and that's because we don't actually have a node setup started for this light. And in order for us to do this, we're going to go over here to the object data properties, and we have to actually use a point light for this setup. So click on point. I'm going to actually move this stuff out of the way here. And what we're going to do is we're going to start adding our nodes. So you can click on this right here that says use nodes, or over here in the object properties underneath nodes, you can click this button and you'll see that it creates a light output, an emission, and nothing else. So what we need before we actually do this is we have to add the IES texture. So hit Shift A. Let me turn on my screencast keys so you can see what's going on. Hit Shift A, texture, IES texture. Then click external, and you're going to navigate to your IES lights that you downloaded. So again, all you need to do is do a search. You can find this. I'll put the file path, or not the file path, but the link in the comments, the description of the video. leomoon.com, and he has in the asset store there an IES lights pack that's free for donation. So give him a donation if you'd like. And we'll go in there and then we'll change this so we can look at this a little bit easier. So we're going to change the sorting by name. So click this little drop down right here, go to name, and then change this to thumbnails. And now we can see all of these different IES lights. And so that this looks a little bit easy to see the obvious changes, we're going to pick something that's a little bit clear. So we're going to start with this 3-lobe umbrella right here. You can see there's an image and then there's an actual .ies here. So you want to click the IES, not the PNG. This is just so you can see what it looks like. So let's double click on this IES here. And then what we're going to do is in your node tree, you need to take the factor and plug it into the strength right there. Okay. And then down here, let's hit Control S to save real quick. We're going to show this in rendered view. And you can see that it's really just blowing out the scene. And that's because IES Textures have a different way of calculating strength. They use a set of mathematics, and we're multiplying that math by 3000 right here. So let's just change this to a 5. And that's a little bit dark, so let's change it to a 15. Still a little bit dark. Let's change it to a 30. Let's try 50. Okay. So there we have that. Now I'm going to zoom around in the scene here so I can kind of show you what's going on, but feel free to just follow me and watch what I'm doing and not really do what I'm doing right now, okay? So here's with the IES light. You can see that there's this sort of lobing effect, okay? Where it's more soft and it has more of a sort of realistic look to how the objects are being lit. Then if we turn that off and turn on our key light, you can see that it's really not as directed and it doesn't really feel as realistic. At least, that's really my opinion and it's the opinion of a lot of people. That's why we kind of use these IES lights to light stuff like this. So let's turn this off and turn this checkbox off and turn back on the key light and then go back to our rendered view. So what you'll want to do if you want to match this correctly or 100%, like I'm not gonna do 100%, but I'm gonna get it kind of close. Um, we're gonna want to try to match the lighting as much as we can, but it's really going to look very much different from the uh, flat lights that we were using for the regular 3-point. So give me just one moment and I will try to match at least the key lighting a little bit closer. So just give me a moment here. That's going to be good enough for now. Now, the next thing that we're going to do, so I used 80 watts for this power here. Now, the next thing that we're going to do is we're actually going to change the color temperature of our light to get it to match closer to what would happen in reality. And how we're going to do that is we're going to be looking at color temperatures according to Blackbody emissions. So if you look up color temperatures, Blackbody, you will see that there are all of these different sort of spectrums that you can check out. And really, what we're going to look at here is if you look at this, where it has like 2 more rows here. So this is from Giandi Grandi or whatever.org. You can see here it says 1000K is red, 1500 is reddish orange, 2000 is yellowish orange, and all the way up to 5500K is white. Okay, so regular sunlight is a different value, but generally speaking, these numbers 3500 or 3000 up to 5500 get used for LED lighting setups inside of a studio. So what we're going to be using is a 5500K white light for this lighting. And it's going to have a little, like kind of a slight effect, but I'll show you what the 3500 and the 5500 look like along with the others with the Blackbody coloring. Okay. So in our node editor here, if you hit Shift A and you do a search for Blackbody, you will click on it and you will see this, and it says temperature 1500. So if you take that color and pipe it directly into the emission, that's what happens. So this is what would happen if a 1500K light or a temperature light was in here. So like a fire, like some sort of campfire or something like that. Now, because we want this to be more of a white light, we're gonna up the temperature here. So if we change this to a 3500, you can see that now it's warmer light. And this would generally be used for something, this would have a yellowish warmer light, usually done for skin tones and things like that. But we're going to pop this up to 5500 because that tends to be more of a white light. Sunlight tends to be somewhere around, I think, 7200 or something like that. So you can see it gets much more blue, but we really don't want that. We want something that looks like a natural indoor light. So 5500 is what we're going to do. And that already is going to give you a much more realistic rendering of your lighting in the scene because we're using real world temperatures, or at least closer to real world temperatures, to color the light. Then we're using this IES texture that's projecting a light source that's more realistic. So next thing we're going to do is we're just going to open up the fill light, and we're going to do the same thing here. We're going to click on the fill light. We're going to click on the use nodes. And what we can actually do here is like we did with the materials. If we jump back over to our key light, we don't even have to turn it on. We can grab these. We can do a box select, copy, and then go back to our fill light and paste that in. And then just pop the factor and pop the color in. And remember, we went crazy here with the power because we weren't using these IES befores. So the key light used 80 watts, which means that our fill light should use that divided by 2, so 50%, so 40. Now, I actually like to use a little bit of a softer, oh, we didn't change the area here to point. Make sure that you change this to point here. That actually looks pretty soft, but I actually want to use a different type of IES light texture that's going to be a little bit softer and illuminate a little bit more of the scene. So I'm going to click on this, and we're going to look for something like, let's do, let's do, let's do this one here, cylinder narrow. Let's try that one. So that one gets a little bit more of that background right there, which is really what I wanted. And this actually looks pretty nice. I might pop the power down just a little bit because it is getting a little hot right here. So let's go to a 30. So this isn't an exact science since we're using a different IES light. So the way it's multiplying is a little bit different. But if we turn on the key, this should be the brightest. And turn on the fill, this should be not the brightest. So it is still is a little bit bright. Let's do 20 instead. And that should be fine. So turning on the key light and the fill light together, that's what we're looking at. Okay, so now let's do the rim light. Turned off my fill and my key, and let's turn on the rim light. That's what it was before with just the area light back here. And we're going to select the Blackbody and IES texture from our fill or our key light. Click on the rim light. Click on use nodes, either here or up here. Then you can copy, paste that into the node editor here. Take the black body, pipe it in, and then take the IES texture and pipe that into the strength. And again, it goes crazy because of the power here. So let's change this to a 10. And area light to a point. And there we have a softer sort of backlit rim light. So now if we turn on all three together, this is what our scene looks like. And then we're going to add back in our HDRI background at a 0.2. And there we have our scene lit up with a new lighting setup. And we're going to go ahead and render this one out. So I'm going to go ahead and save this and then hit F12. Okay, so there we have it. Everything has been rendered out, and this is put through the compositor. We don't really have to change anything else since it's the same as it was before. So I'm just going to go ahead and go to Image, Save As, and we will call this IES Lights version 2, and then Save as Image. Oh, make sure that you take the compression down. So Save as Image. So I'll put on the screen here a comparison between the two. So hopefully you can see quite a bit of a difference between the two, or at least some sort of decent difference between the two. And you hopefully are preferring this one with the more realistic lighting. And hopefully you learned a lot about how to light and render your scene. So the next part is going to be on using Radeon Pro Render, and I really do recommend that you, especially those who have not as high-powered computers as I do, to really take a look at it because it does. Uh, it is a faster engine. It's doesn't have as much versatility as this one as far as the IES lights and shadows and stuff, which I'll talk about later. But it definitely is worth taking a look at and utilizing as best you can for whatever projects that you have available. So I will see you guys in the next part in talking about the Pro Render engine. And if you like the content and you're happy with what's going on here, please like and subscribe and put a comment in the video down below and let me know how you're doing on this project series. And I will see you guys next time.